G'day guys, Clint from Hermit Fabrication, just bringing you another quick tip. This is a 5-inch aluminum mandrel bend. It's quite often you need to cut these bends at certain angles, and working out where exactly to cut can be a bit tricky. If you get your cut skew-if to either side, the end of the cut ends up being an oval, and it's quite hard to match up your pipes to cleanly. Okay, this isn't the only way, it's not the best way, but it is one of the ways. I used it for many years. I've now have 3D printed jigs, but I still use this for bends that I don't use often, I don't have a jig for, like this 5-inch bend. So, I want a 60-degree angle, and I need to know where to cut it. Most mandrel bends come with a short leg at each side. I've actually already cut this one, so it's right at the start of the bend. But to work out where that start point is, I put a straight edge on the flat section, and you move it forwards, you'll start to see the straight edge lift. Just as that point where a straight edge lifts is the start of the bend. So that's at 25mm, which is pretty much 1 inch. So I'll mark that. I'll do that on the inside radius, and then I'll do that for the outside radius as well. 25. You can actually see, I'm not sure if it's picking up the camera, there's a line here from where the mandrel die grabbed the pipe. So sometimes that's a telltale sign as well. So I've just got that marked on the outside radius and the inside radius. So we know that is 90 degrees from those 2 points. So just your basic fabric tape, nice and flexible. I put that on the start point and then measure how far that is to the end of the bend. Be careful that it lays flat. And that is 205mm. Doesn't matter what units you use, but yeah, just keep it all the same. It's 205mm. Now you take your calculator. So 205, divide that by 90. That gives us, upside down for you guys, 2.27mm. So for every 1 degree of bend is 2.27mm. So I'll just write that down. I've actually got other bends that I've done before. I keep a, you can see it, I keep a note in my phone. So 2.27, I actually wrote 2.26 from last time I did this. And then we do the same on the outer radius, outer diameter, to that mark, which is, just get that straight, 395mm. Now you've got to make sure your tape's straight on the outside. If it's sort of, you know, if you're going across like that, it's obviously going to be the wrong measurement. You want to keep on the very outer surface. So what was it? 395. So 395 divided by 90 is 4.38 recurring millimeters. So I've got that in my notes. The inner is 2.26mm per degree. The outer is 4.38mm per degree. Alright, so now I worked out I need a 60-degree bend. So for the inside, 2.27 times 60, 136.2 millimeters. So starting from the top again, okay, where's my texter? 136.2-ish. I'll draw a line there. So that's 60 degrees from here to there. We want the same on the outside. So we want 60 times, it was 4.38. 4.38, it's 262.8, so we'll call that 263. So on the very outer diameter, 260. 2.8, right about there. Okay, now we've got our 2 points that we need to cut here and there, but you say you got to cut this out with a hand grinder. You want to know the whole length. You can eyeball it and sort of just draw it along your line. That's one way. Another way is just an elastic band. Stick around there. It works best when you get all the twist out of the band. This band's actually quite old, it's probably going to snap on me. You go around, get the twist out. There. And you line it up on your mark, inner and outer. Just give it a little lift and a snap. And it generally lays pretty damn close to straight. When you look along it, you can actually sort of tell when it's not straight pretty easily, and you can sort of shift it just by eyeballing it. You can shift that along until it's a nice straight line all the way around. See there, it's a little bit off. And that will get you pretty close. You can go along and mark that now all the way around, which I'll do just for shits and giggles. Now you could do full lines, just doing a dash line here. And there you go, that would be, now obviously you want to cut on this side of that dash line. You know, I lay my grinder actually there if I was doing it by hand. Another way is just a worm drive clamp. You can put that over the pipe. This will stay straight. This is probably slightly more accurate than an elastic band if you've got a clamp the right size. Yeah, you can put that right on your line, and you can see it's already lined up, if you can see, on that side. Let's see how close we were with our dash line. Let's put it on the other side. Okay. Yeah. So it's probably slightly more accurate. You can see my dash line matches pretty well. So that's another way you can do it. You actually tighten that up. You can draw your line. Then you cut it on with a grinder. I'll show you the way I actually do it because I've got a horizontal bandsaw. Just give me a minute, I'll get you set up at the bandsaw and I'll show you how to do the rest of the cut. Alright, we're here at the bandsaw. I've got my digital level and I'll set that to 0 while sitting on the bandsaw. And then our pipe. Just put that roughly in place for now. Screw it across. Now below the cut has to start where we marked it, so let's just lower it down as close as we can. So we know left and right it has to go there in line with the lines we marked, but that could be here or there. So what we do, I'll line that up. We want a 60-degree cut. So I'm looking, I don't know if you can see me, but I'm looking down the blade, make sure it's lined up with that cut. Put it on here and I'll adjust that in the right direction until it gets to 60 degrees, right about there. Looking down the blade, make sure that's lined up still, and then I'll tighten the vise. Last check is this can be twisted a touch, which it actually is. Smaller bends that fit in the vise better will get straightened up. Because this is so big, it can be a little bit twisted. So let's just loosen it. And I'll just turn that. I'm just looking down here to make sure that's level. You could actually put the level on it and it'll tell you 0 degrees, but I know I can get pretty good by eye. But now I've moved that, I'll double check this. It's at 58, 59, 60. I've actually got to go that way a touch. Alright. 60.1, 60. Okay, tighten that up. Another sanity check. You know, if I just want to be sure, I can see my mark at the bottom here. I can put that on the blade and make sure that's lining up with my mark. Easy to see on this side. And it is. So I know we're pretty much spot on. So I'll just cut this quickly. You see I put my hand there, it's probably not the best thing to do. It's more a problem with stainless because it's harder to cut. But the blade can actually twist this. I don't have that problem anymore because I use 3D printed jigs. But yeah, if I felt that move at all, I'd quickly stop the feed and the blade. But she held firm. Let me just clean up the burrs on this. And I'll double check it on the table. Alright, I think the rain's let off for us a little bit. So we got that set to 0 degrees. And then we check the bend. We ended up with 50, just under 59 degrees. So you can get quite close. If I needed this to be exactly 60, I could take it to the the belt sander and shave a touch off, you know, a bit more from the outside or the inside, whatever it is, and get that exactly the 60 degrees. But for this application, you know, 1 degree off will be fine. But yeah, that's one easy way to do it. You know, if you don't have a bandsaw, could have used a grinder, could have just followed your lines. You see we're pretty right on the line there. No, you can't. There you go. But now I've got these 3D printed jigs that I've made myself. You can buy them online, but every pipe bend manufacturer has a certain slightly different centerline radius, and there might be slightly different diameters, so I find it's better to make them myself. I've got angle marks on there. So I've clamped this in the bandsaw. I can adjust the angle and cut it here. This one I actually cut straight through, and because they are disposable, I needed to make a 2-into-1. So I could sit this in the bandsaw and I cut straight through here, so I cut that pipe in half. So very useful. I'll go over these in more detail in future. That's it for today. I've been busy working, but I thought I'd just share a quick tip, and hopefully it'll help you working on your own gear. So I just thought I'd show you the finished product. That's one way you can mark and cut out your mandrel bends for your exhausts and intercooler piping. This happens to be a FG XR6 Turbo Falcon, expecting around 1000 horsepower once it's fully tuned. and I did the intercooler piping, fit the intercooler and the 4-inch exhaust system. But until next time, I'll see you later. 5-inch intercooler piping is huge. Oh.